Hello, good day. For this video presentation, I will be talking about the first lesson for our electromagnetic course, which is Vector Analysis Part 1. By the way, our reference book will be Electromagnetics by Height. Okay. Throughout this course, we will be dealing with a lot of physical quantities. These quantities may be classified into two. We have scalar quantities, which pertains to a quantity whose value may be represented by a single positive or negative real number. For example, distance times temperature. So these values have only magnitude. On the other hand, we have the vector quantities, which have both magnitude and direction in space, like force, velocity, acceleration, and others. Electromagnetics will be mostly concerned also with fields. A field, or scalar or vector field, may be defined mathematically as some functions of that vector which connects an arbitrary origin to a original point in space. So later on, we will be we will give an example. We will be understanding that a little more. So, hindi pa siya masyadong, hindi pa natin masyadong maintindihan dito, pero mamaya, makikita natin yung difference ng field dito sa isang vector lang. So, sa general rule natin sa pagsulat ng scalars and vectors, para hindi tayo malito at ma-distinguish natin which is which, so gagamit tayo, okay, sa mga printed materials natin, kagaya ng exams and quizzes. Okay, ang vector natin will be indicated by a boldface type. So, hindi masyadong halata dito, pero naka-bold. Ibig sabihin, mas makapal yung font niya. Then, yung scalars naman natin will be printed in italic type. For example, as you can see. Then, sa mga solutions natin na longhand or yung handwritten, i-indicate natin na vector siya by drawing a line or an arrow over the vector. So, lalagyan natin ng line or arrow yung taas to indicate that it is a vector. Kapag scalar, wala siyang arrow or vector automatically. Yun yung magiging rule natin from now on. So, one fundamental aspect to understand is how vectors behave. We can understand this by familiarizing ourselves with a set of rules that vectors follow, like vector arithmetic, vector algebra, and later on vector calculus. Some of these rules will be similar to what we already know, such as in scalar algebra. Some will be slightly different, and some will be entirely new to us. So let's start with what we call the vector addition. The vector addition, or addition in vectors, follows the parallelogram law. Okay. Ano ba yung parallelogram law? It states that kapag meron tayong two vectors, as you can see here, we have vectors A and B, and we create a parallelogram by simply creating another vector or similar vector parallel to A, then also a similar vector parallel to B. Yan, para makakreate tayo ng parallelogram. Then, the sum of A and B is the diagonal or the longer diagonal of the parallelogram. So, pwede rin siyang vector addition also follows the triangle law. Ito, kapag triangle law states that kapag dinugtong natin yung vectors from tail to head, so we have vector A here, then dinugtong natin dun sa dulo ng arrow ni A yung B, then ang sum ng A and B will be from the beginning of A dun sa dulo ni B. So that is vector addition in algebra. Vector addition also obeys commutative law. Yung parang alam natin dun sa scalar algebra, ibig sabihin A plus B equals B plus A. So kapag pinag-add ko siya at binaliktad ko, parehas lang yung makukuha ko, or that is commutative commutative law. Then it also obeys associative law, which is the same as yung alam nating associative law before. That is, if a group A plus the sum of B plus C is equal to the sum of A plus B plus C, where A, B, and C are all vectors. Then, another thing to note is that complanar vectors may also be added by expressing each vector in terms of their components. Ito yung napag-aralan natin dati, which is what we call the component method. Ibig sabihin, yung vectors, pwede natin siyang hati-hatiin sa kanyang components. For example, ang alam ko yung na-encounter natin is meron tayong x and y component. And kapag pinag-add natin yung vectors, ang ginagawa natin, pinag-add din natin yung components nila. So, pinag-add natin yung mga x component nila and the y components. Ngayon, yung rule of subtraction sa vectors is follows easily from that for addition. So, dahil ang a minus b ay parehas lang sa a plus to negative b, it follows na the sign or direction of the second vector is reversed and this vector is added to the first rule by the rule of vector addition. So, para lang siyang addition ulit, pero ang ginawa lang natin is ni-reverse natin yung sign ng pangalawang vector, then proceed to addition. That is the same as subtracting the two vectors. So, sa vectors naman, vectors may be multiplied by scalars. So, multiplication. For example, we have here the quantity r plus s is multiplied to the quantity a plus b, where a and b are vectors and r plus s are scalars. So, si vector, pina-follow din niya yung distributive law. So, i-distribute natin at saka yung associative law. I-distribute natin si r plus s for both a plus b, and then simplifying further, madi-distribute natin si r at s. So we will have ra plus rb plus s plus sb. So, kailangan nating i-take note that r and s are scalars. So this is multiplication of vectors by scalars. Iba din kasi kapag nagmumultiply tayo ng vector to vector, which we will discuss later on. So dito, if we multiply a scalar by a vector, para rin siyang dun sa natutunan natin dati. I-apply lang natin yung associative and distributive laws. Then, ang division naman, it is just a multiplication, pero i-multiply natin sa reciprocal ng scalar na yun. So, parang 3 divided by 2 is just equal to 3 times yung reciprocal ng 2, which is 1/2. So, para lang siyang multiplication. Pero ang multiply natin is reciprocal ng scalar. Yun yung division. Then, another important property is that two vectors are said to be equal if their difference is 0. So, masasabi lang natin na equal ang dalawang vectors kapag ang difference nila ay 0. That is, vector A minus vector B equals 0. Then, in order to describe vectors accurately, some specific properties like length, direction, angles, etc. must be given. There are a lot of methods to do this, but the simplest way to describe a vector is through a Cartesian or the rectangular coordinate system. So medyo familiar na tayo sa Cartesian coordinate system, pero yung alam natin is that dalawa lang or 2D. 2D planes, the X and Y plane. Pero this time, gagamitin natin is 3 dimension. We have the X and Y Z plane. So in the Cartesian coordinate system, we have 3 coordinate axes which are mutually right angles to each other. And they are called the X, Y, and Z axis. So wala namang masyadong pinagkaiba dun sa naintindihan natin dun sa 2D. Yun nga lang, nadagdagan lang ng bagong plane which is pointing towards U. Ayan. So, this type of coordinate system is right-handed. So, ito yung karaniwang ginagamit. Right-handed siya. Ganyan yung position. X is pointing towards U. Y is pointing to the right. And Z is pointing upwards. So, tinawag siyang right-handed Cartesian coordinate system kasi pag in-imagine mo yung screw, yan kapag ina-unscrew mo yung screw, yung pinapalawagan mo yung screw. So kapag ni-rotate mo yung X papuntang Y, aangat si Z. Ganon yung screw, di ba? Yung screw kapag pinapalawagan natin, i-rotate natin yung screw from counterclockwise direction. At kapag ni-rotate natin, aangat yung screw. So, ganun dito sa coordinate system natin. And another method din kung bakit siya right hand or another explanation para hindi mo siya makalimutan is gamitin mo yung kamay mo. Yung x-axis, yun yung magiging thumb or hinlalaki. Yung y-axis, yun yung forefinger or hintuturo. Then the z-axis will be the middle finger. Then yung thumb will be pointing outwards. Ayan. Makikita natin or masisimulate natin, magagaya natin yung Cartesian coordinate system. Dito sa Cartesian coordinate system, madedefine natin yung point. Kagaya din sa 2D natin by giving its coordinates. Sa 2D, meron lang tayong xy. Dito, meron tayong x, y, and z coordinates. For example, yung point na nakikita natin dito, this, yung point P, which has coordinates 1, 2, 3. Ibig sabihin nun, ang x-coordinate niya ay 1, ang y-coordinate niya ay 2, at ang z-coordinate niya ay 3. Which means, okay, 1 point siya, 1 unit away from the origin towards x-axis, 2 units away from the origin towards the y-axis, or away from, papunta dun sa positive y direction, then 3 units from the origin towards the positive z direction. So, ganun lang din naman yung sa natutunan natin dati, nadagdagan lang talaga ng x or ng pangatlong coordinate. Ngayon, to describe a vector in the Cartesian coordinate system, let us first consider a vector r extending outward from the origin. So as we can see here, meron tayong vector r nagsimula sa origin 0, 0, 0, then nag-extend siya outward, indicated by the arrow. To identify this vector, logically, we express it as a sum of its components. Kung mapapansin natin, okay, using its components, magkakaroon siya ng component dito sa x-axis, sa y-axis, and the z-axis. And through vector addition, we can say that vector r is just equal to the sum of these components, which is equal to x plus y plus z. These component vectors have magnitudes which depend on r, pero kung mapapansin natin, they each have a common and constant direction. Si x papunta sa direction ng x-axis, si y-axis lang, si z-axis lang. Okay, although nakadepende yung magnitude nila dun sa magnitude ni r, yung direction nila unique. Si x dito lang ang direction, si y dito lang, si z dito lang. Magkakaiba sila. Because of this, okay, we should use unit vectors na tinatawag, which have a unit magnitude but directed along the coordinate axis. Yung tinatawag natin unit vectors, para lang siyang basehan. Okay, walang pinagkaiba dun sa units natin. For example, what units are we used, okay, to quantify length? Meters, for example, meters, 3 meters, 8 meters. Parang ganun din sa unit vectors. Parang siya yung basehan. Okay? Para ma-determine or ma-quantify natin gaano siya kalayo along x, gaano siya ka-extended along y, gaano siya ka-extended along z. So, yung unit vector, yun yung magiging basehan natin. Ang magnitude niya ay unit magnitude, pero yung direction niya directed along the axis. So, ito nga yung mga unit vectors natin tinatawag. We have unit vectors along x, which will be indicated, unit vectors will be indicated by the boldface or letter A, small or lowercase a pero nakabold. So, this is unit vector A along x in the direction of x-axis. This is unit vector A in the direction of y-axis, and unit vector A in the direction of z-axis. Again, para saan itong unit vectors? Sila yung magiging basihan natin kung gaano ang isang vector ay extended along the x-axis, the y-axis, and the z-axis. Example, we have here vectors rp and rq. Okay, vector rp extended, okay, is pointing outwards. Nagsimula sa origin 0, 0, 0 papunta kay point P, which is has a coordinate axis of 1, 2, 3. So, ano ngayon yung vector rp? Okay, since nagsimula naman siya sa 0, 0, 0, shortcut na yon, automatic, ang magiging vector natin will be, ikukopyahin lang natin yung coordinates. Kung ano yung x, yun din yung multiply natin sa unit vector. For example dito, yung point natin na pinuntahan ni RP is from origin to point P, which is 1, 2, 3. So, magiging vector natin is AX plus 2AY plus 3AZ. Saan galing po yung 2 and 3? Dun sa coordinate axis ni P. Kasi nga from origin to P tayo. Okay, si AX dapat may 1 dyan, pero di ba nga, inuungit natin kapag meron ng 1. So, yung components, o yung scalar components ng vector na RP ay galing lang dun sa coordinates 1, 2, 3 ni P. Ayan, kaya naging AX, 2AY, 3AZ. Yan si vector P. Si vector Q, kung mapapansin natin, ay nag-extend outward, nagsimula sa 0, 0, 0 or the origin, papunta sa point Q which is 2, negative 2, 1. Then nagsimula siya sa origin, automatic, kukopyahin na lang din natin yung coordinates ni X, ni Q. XYZ coordinates ni Q. So we have RQ, vector RQ equals 2AX minus 2AY plus AZ. Again, saan galing si 2, negative 2, and yung 1? Galing siya dun sa coordinates ni Q. Okay. Sir, paano na ngayon kapag hindi siya galing ng origin kagaya nito? We have the vector RPQ extending from point P to point Q. Okay, ang magiging formula na ngayon natin is ang vector RPQ will be equal to vector RQ minus vector RP. So, in-apply lang natin dito yung triangle law or the parallelogram law pala. Sorry. Kapag nag-create tayo ng parallelogram, mapapansin natin, si RPQ will be the sum of RQ and RP. Or mali. Si RQ pala ay sum ng RPQ and RP. And since ang kinukuha natin sa RPQ, nilipat siya, kaya naging minus to. So, therefore, yung RPQ will be the difference of the two vectors RQ and RP. So, as a shortcut, isipin nyo na lang, para kunin yung resultant vector na RPQ, ima-minus nyo lang yung nahuli, RQ, kung mapapansin nyo, dito, nahuli si Q. So, mauna siya rito, minus RP, kung saan siya nanggaling, vector RP. At since dahil nakuha na natin si RP and RQ dito sa umpisa, ayan, gagawin natin component method. Okay? Combine lang natin yung like terms kung along AX lang. So dito, 2 minus 1 kasi 2 yung RQ tapos 1 kay P. Then, along Y or unit vector AY, negative 2 minus 2 and so on. So medyo naputol, meron tayong AZ dito. And simplify, very basic. Makukuha natin that the resultant RPQ is equal to AX minus 4AY minus 2AZ. Okay, sabi natin vectors have both magnitude and direction. But there are times na ang kailangan lang natin is yung magnitude. So, paano natin kukunin? For example, we are given here vector b at ito yung kanyang equation, or in terms of its unit vectors directed along x and y-z axis. So si bx, yun yung scalar component or yung component na tinatawag or coefficient. So sa algebra, tawag natin doon coefficient niya. So, pero dito, tawag natin scalar component. So bx, by, and bz yung scalar components. Bx, scalar component along the direction of the unit vector x, in the direction of unit vector x. By is a scalar component in the unit vector in the direction of ay, and bz sa z din. Makukuha natin yung magnitude ng vector b using the formula. So para lang siyang Pythagorean theorem, pero dahil tatlo yung coordinate axis natin, in-square natin. Dinagdagan natin tatlo. So yung magnitude ng b, ang magiging symbol natin is yung parang absolute value. So the magnitude of b equals the square root of bx squared plus by squared plus bz squared. Where bx, by, bz is yung mga scalar components ni vector b or yung mga katabi ng unit vectors natin ax, ay, and az. Yung unit vector naman, hindi lang siya laging directed sa x, y, and z axis. Pwede tayong kumuha ng unit vector in the direction of a certain vector. For example, if we want to find the unit vector in the direction of vector b, ito yung formula natin. I-divide lang natin yung vector b mismo divided by the magnitude of vector b. At dahil may formula na tayo for magnitude of vector b, substitute lang natin. So, the unit vector in the direction of b would be equal to the vector b divided by or all over the square root of bx squared plus by squared plus bz squared. Or sa definition, unit vector in the direction of b is equal to the vector b itself divided by the magnitude of vector b. So para maintindihan natin, so specify the unit vector extending from the origin toward the point 2, -2, -1. Okay, first, anong gagawin natin? Kunin muna natin yung vector rg. Okay, dahil nanggaling naman siya sa origin, so kinopya lang natin yung coordinates ni g. Okay, supposedly kasi ma-minus mo siya, pero dahil 0, 0, 0 naman yung origin, copyahin mo na lang yung coordinates ni g. So naging, ang vector g natin, extending from the origin to the point g is 2ax minus 2ay minus az. Then next, we get the magnitude. Formula natin, square root ng squared, squared, squared. So square root ng 2 squared plus the square root of -2 squared plus the square root of -1 squared, which is equal to, okay, very basic, 3. And para makuha natin finally yung unit vector, yung mismong vector natin, i-divide natin ng magnitude niya. So our vector is 2ax minus 2ay minus az divided by 3 all over 3. Then simplify mo lang. So gagawin mo, distribute mo lang yung numerator or denominator pala sa mga numerator. So ito lang din. So ito na yung magiging unit vector natin in the direction of g. Ganun na siya kadali. Okay, ito na yung kanina yung define natin in words, pero hindi masyadong malinaw. Mas madali siyang i-explain. Tinatawag natin vector field. Kung yung vector natin kanina ay represented in terms of its scalar components, at saka ng unit vectors along x, y, and z. Ang vector field ay ma-represent natin. If you represent a position vector r, then a vector field g can be expressed as a function of g, a function of r. Ibig sabihin, yung mga kaninang scalar components natin, mapapalitan na ng functions mismo. So, meron pa rin tayong unit vectors along x, y, z. Pero, yung mga katabi na nila is hindi na scalar components. Itong g r of x, or gx of r pala, gy of r, and gz of r, ay functions na ng x, y, and z. Ibig sabihin, hindi na siya scalar lang, hindi number lang yung makikita mo, kundi functions na. Functions na x, y, and z. Yun yung kaibahan ng vector field dun sa common lang na vector. Okay. Then kanina, i-explain natin yung multiplication ng vector multiplied by scalar. Okay. This time, ito naman yung mga what if multiply natin yung vector into another vector, or vector to vector multiplication tinatawag. Okay, meron tayong dalawang types ng vector multiplication. Yung una is the dot product, or yung tinatawag din natin scalar product. So, definition ng dot product is that A dot B, yun yung basa doon, A dot B, kaya siya dot product, is equal to the magnitude of A times the magnitude of B times the cosine of angle between A and B. Okay. Kailangan nating maintindihan na yung dot product is scalar. So, yung makukuha nating sagot dito, scalar. Hindi siya vector, scalar. Ibig sabihin, number. And also, it obeys commutative law. Ibig sabihin, ang A dot B ay equal lang sa B dot A. Ano pa? Ngayon, dito sa A formula natin na to, medyo mahirap siya gamitin, lalo na kung angle na yung pinag-usapan sa vector. Sa vector, kapag meron ng angle dun sa formula, medyo mahirap kasi hanapin yung angle between two vectors. Hindi naman sa mahirap, pero hassle. So, gawan natin ng paraan. So, gamitin natin yung components ng vector A at ng vector B. So, ito yung components niya. Break down natin siya into its component vectors directed along x, y, and z axis. So, in terms of unit vectors, ax, ay, and az. At dahil ino-obey niya naman yung distributive law, so pwede natin gawin to. And then, i-distribute natin isa-isa. Then, i-apply natin yung formula na to sa taas. Eh, deserve. Para pinahirapan natin yung sarili natin kasi dumami yung solve natin. Hindi. Mas straightforward siya. Lahat ng mga unit vectors, lahat ng dot product ng unit vectors na magkaiba yung direction, kagaya ng ax at ay, ax, hanggang sa zy, az, equal niya yan 0. Kasi kung mapapansin natin, ang angle between the x and y axis ay 90 degrees. At kapag kinuha natin yung cosine, di ba dun sa formula, magnitude of A, magnitude of B times cosine ng angle between the two vectors. Kapag kinuha natin yung cosine 90, ang magiging sagot ay 0. So, yung pag dinistribute mo yung kanina, yung tatlong 3x3, or yung multiplication ng components niya, dadami yung terms, magiging siyam, pero 6 dun makakancel kasi nga magzi-0. So, magiging labas, tapos bukod dun, yung dot product ng sariling ng isang unit vector sa kanyang sarili ay 1 kasi nga since ang angle between them kapag parehas naman na x-axis 0 yung angle between them at ang cosine 0 ay magiging 1. So masisimplify yung masisimplify yung magiging distribution, dot product natin into this. Ang matitira na lang doon is ax bx plus ay by plus az bz. So ito yung magiging straightforward and shortcut method natin para kunin yung dot product. So hindi mo na kailangan ng sa formula na to yung angle between the two vectors. Ang kailangan mo na lang is yung scalar components niya. Then, isa pang note to remember is kapag kinuha natin yung dot product ng vector sa kanyang sarili, or a dot a, ang makukuha natin is just equal to the square of the magnitude of the vector itself, or magnitude of a squared. Tapos, yun nga, yung unit vector a dot unit vector a or a unit vector dotted to itself, ang sagot ay 1. Okay, isang example or application ng dot product is yung tinatawag natin component ng vector in a given direction. For example, dito, meron tayong vector b. Hahanapin natin yung component ng vector b in the direction of vector a. Yun yung isang application ng dot product. So, magdalawa yan. We have the scalar component and the vector component. Para makuha yung scalar component, which is b dot a, yung formula natin kanina, magnitude ni b, magnitude ni a, cosine ng angle between b and a. Pero dahil unit vector to, ang magnitude niya, unity or 1. So makakancel lang yung a. Kaya magiging b dot unit vector a will be equal to the magnitude of b times cosine of angle between b and a. Yun yung scalar component. Yung vector component niya, imumultiply lang natin yung makukuha nating scalar component dun mismo sa vector na a. Ayan, para magets, magbigay tayo. Okay, sometimes yung dot product tinatawag din projection. So b dot a, ang basa minsan dyan is the projection of b or projection of vector b in the direction of small letter a yun na. Sorry, typo. Example, consider the field. Yan, field na siya. Yax minus 2.5x ay plus 3az and the point q 452. Find g at q, the scalar component of vector g at q in the direction of an 2/3 ax plus 1/3 ay minus 2/3 az. Letter c, the vector component of g at q in the direction of an and the angle theta ga between grq and an. Okay, kung mapapansin natin, yung field natin, ito yung sinasabi ko mga field, yung components niya, hindi na scalar, kundi mga functions na. So, meron kang y and kikita x dyan, mga variables na x, y, z. So, solve natin. Yung g at q, very basic lang. Ibig sabihin nun, substitute lang natin yung coordinates na q dun sa g. Kaya nga g at q, vector g. So, yung coordinates ni q natin, 4, 5, 2. Tapos yung g natin, ito. Function of x, y, and z. Kasi nga field siya. Substitute lang natin. So, dito sa point q, ang x natin ay 4, ang y ay 5, z ay 2. Substitute lang natin yung mga values na yun dito sa g. So, we have, since y natin ay 5, magiging 5 times ay x yun. Minus 2.5 times x natin ay 4. Then, 3az, walang z. Then, Simplifying, we have 5ax, 2.5 times 4 is negative 10, plus 3az. Yun na yung g at q, or we have g as a function of our q. Next, kunin natin yung scalar component. So yung scalar component ay, so ano yung sabi, dot product lang din. Dot product na g dun sa direction ni an. So ito yung grq natin na nakuha natin sa letter A. Ito naman yung given na an. So ang dot product nila ay, so shortcut, hindi natin gagamitin yung may angle. Ang gagawin natin yung kanyang mga components. So i-multiply natin yung components along ax, that is 5 times 2, 3, plus yung components along ay, then az. So x kay x, y kay y, z kay z. So multiply natin, pag simplify natin, kuha natin the scalar component is negative 2. Kuha yung vector component, i-multiply lang natin yung scalar component dun sa mismong unit vector kung saan siya directed. Yan. So nakuha na natin kanina itong g dot an, which is negative 2. I-multiply lang natin sa mismong an na given. Then, distribute lang. Then, yan na yung vector component. Then, last, para makuha natin between grq and an, yung formula natin, g dot q equals magnitude of g cosine ng theta ga. Nakuha na natin yung g dot a, which is negative 2. Ang magnitude ni g nakadepende dun sa scalar components niya. So, square root ng 5 squared plus negative 10 squared plus 3 squared. Cosine yung angle na hinahanap. Then, simplify, we have negative 2 square root of 25 plus 100 plus 9. Simplifying further, we have yung itong may square root magiging square root ng 134, and dahil kailangan ko ng angle, di-divide ko siya. Yan, isolate ko, then arc cosine or inverse cosine na lang para makuha yung angle na 99.9 degrees. Okay, yung pangalawang type ng vector-to-vector multiplication is yung tinatawag nating cross product or the vector product. Kanina, kung mapapansin natin, tinawag siyang dot product kasi, or scalar product, kasi yung nakukuha nating sagot ay scalar value or scalar quantity. Dito, ang makukuha natin is vector. Ibig sabihin, dapat may makita kong ax, ay, and az dun sa sagot. Okay, ang formula natin, a cross b equals magnitude ni a, magnitude ni b, sine ng angle theta between a and b, times the unit vector n. Okay, anong unit vector n? Yung unit vector n, ang direction nun is perpendicular both kay a and b. So, parang ganito. So, imagine natin yung screw ulit. So, if you have vector a and b, okay, ang direction ng a cross b ay perpendicular sa kanilang dalawa. So, pababa. Ganun ang direction ni an. Unlike yung dot product na ngayon, kung mapapansin natin, kung titignan natin yung mga coordinate axis, yung mga unit vectors directed along the x-axis, mapapansin natin na kapag kinuha natin yung cross product ng ax and ay, ang vector na perpendicular to these two vectors ay yung isang coordinate. Kasi nga, diba, yung tatlong coordinate axis, x, y, and z, are perpendicular with each other. So, ang ax cross ay is just simply az. Then, it follows also, yung ax cross az ay yung ay, at yung ay cross az ay yung ax. Okay, unlike scalar product or the dot product, ang cross product does not obey commutative law. Ibig sabihin, yung A cross B ay hindi parehas sa B cross A. In fact, ang B cross A ay equal sa negative ng A cross B. Mag-iiba yung direksyon. Okay, hindi niya ina-obey ang commutative law. Okay, tandaan natin yan. Okay, ginawa natin ito kanina dahil ina-obey niya naman yung distributive law kagaya nun sa dot product. Binake down natin siya into its components tapos in-apply natin yung formula. So try natin kung pwede ba siya dito. So, kapag cross multiply natin, yan, magkakaroon tayo ng 9 terms. Sir, may makakancel po ba dyan? Meron. So, pansinin natin yung mga nakakross sa sarili niya. For example, AX cross AX. So, kapag in-apply natin yan sa formula, since same naman yung vector, ang angle natin ay 0. And sa formula, ang sign ang gamit, and sign 0 is 0. So, makakancel lang itong mga to. Ito, tsaka ito. So, matitira 6. Then, papansin natin na ang AX cross AY ay is AZ, AX cross AZ ay AY, AY cross AX ay AZ. So, kapag ginawa natin yun, ay okay. Sinimplify natin, ito yung magiging kalalabasang formula. Yan. Ang A cross X ay A cross B equals itong formulang to. So, medyo mahirap siyang i-memorize kasi mahaba. Pero kung marunong kayong mag-determinant sa matrix, same lang yung formula. So, kaya minsan, ganito ang ginagamit na formula. Yung naka-matrix siya, naka-matrix si AX, AY, AZ, then yung kanyang mga scalar components, ang dalawang vectors na pina-cross product, then kukunin nyo yung determinant. So, bago ba kumuha ng determinant? Yan, i-ano na lang natin sa example para magets. For example, meron tayong vector A, 2ax minus 3ay plus az, tapos vector B, negative 4ax minus 2ay plus 5az, determine A cross B. So, kapag ginamit na natin yung ganito. So, nilista natin yung ax, ay, az, tapos si 2, negative 3, 1 at negative 4, negative 2 ay components ni A and B respectively. So, paano po gumamit ng determinant? Uulitin lang natin yung ax and ay, tatabi natin dito sa tabi niya. Yan. Yan ang gagawin natin, i-multiply natin lahat ng tatamaan ng diagonal na to. So, i-multiply natin si ax, pababa kay negative 3, pababa kay 5, or ax times negative 3 times 5, plus, pababa, ay times 1 times negative 4, plus, az times 2 times negative 2. Lahat ng pababa, i-add mo. Ganon din sa pataas. Lahat ng pataas, i-add mo. Then, pagsusubtrakin natin yung dalawang sum na makukuha. So, lahat ng pataas, negative 4, negative 3 times az, plus negative 2, negative 1ax, then 5, 2ay. Then, ang shortcut, ang susunod is yung sum ng pababa minus sum ng pataas. So, ito yan. Ito yung lahat ng pababa. Then, ito naman yung pataas. Isasubtract natin yung isa't isa. Simplify na. Ayan, A cross B equals, ayan, kinopya ko lang yung kaninang slide. Pag sinimplify natin, Ito yung mga pataas. Ayan, negative 3 times 1, negative 15, negative 4 times 1, negative 4. 2 times negative 2, negative 4. Then sa pababa, minus yung pababa. Okay, minus minus yung mga pababa. Negative 4 times negative 3 is 12. Negative 2 times 1 is negative 2. 5 times 2. Then, wala tayong magagawa dyan. Ang gagawin natin is pagsamahin natin yung mga pare-pares na component. So, huwag kayo malilito kasi hindi yan naka-arrange. Lalo na itong pangalawa. So, tingnan natin yung mga similar terms. Negative 15 kay AX, tapos dun sa baba, minus negative 2AX. That is negative 13AX. So, sorry na naulit yung minus. Kay AY, we have negative 4AY sa taas minus positive 10AY sa baba. So, negative 14. Negative 4AZ sa taas minus 12AZ sa baba. That is negative 16. So, yan yung first part ng vector analysis. Kung meron tayong suggestions or comments, clarifications, or questions, okay, i-contact nyo lang ako dun sa Google Classroom natin or sa Messenger, sa group chats. Or, i-raise nyo yung question during our video conference. Okay. Thank you and stay tuned para sa part 2.